Hi, I'm David Millington. I'm the C++ product manager here at Embarcadero, and I'm going to give a lightning talk on C++ standard algorithms. So the C++ standard library contains a vast amount of things, but one of its most useful areas is the algorithm header. And this contains 40 or more methods that run on ranges. So a range is basically something that can be iterated over. So a great example is a collection begin-end, or of course any subset of iterators pointing somewhere inside that collection. So these do a wide variety of things. Many of them avoid manual looping. The easiest example there is the algorithm called for each. It runs a particular method, such as a functor or a lambda, that you pass into the for each method, and it runs that method for every element, and that is a direct loop replacement. So why would you want that? Well, basically so that you don't have to write a loop. You end up writing less code, and you can pass in a little function object, which is a very clean way to run something for every element. But of course, when you're writing a loop, it's longer code than a single method call, and of course there's always the possibility, however unlikely it is, that you might end up with a bug in that loop. Especially if you're using indexes, for example, to loop, you might have an off by one error or something similar. So following the principle of code that you don't write can't be buggy, then you avoid loops with some of the algorithms that are meant to avoid manual looping. Another example might be if you want to find an element in a collection. How many times have you written a loop that goes from the begin to the end of a collection to see if something exists? Well, an algorithm to do that already exists, and it's very widely tested, and it's reliable, and so it's a good idea to use it. But of course there are a whole bunch of other interesting algorithms as well. Copy backward, for example, is an interesting one that will copy all the elements in reverse order, and replace if will go through an entire range and then replace an element, but only if it meets a certain condition. There are others like sorting a range of elements, or shuffling them into random order, or binary searching through them, and similar things like that. So vast majority of really useful algorithms. So let's just look at a few in practice. So I have a simple application here that's going to demonstrate a few of the algorithms. As I said, there are 40 or 50 of them, and I'm just going to cover a tiny fraction of these, some of the most common, I think, or ones that are representative of a group of functions. There are some here that have very similar related functions, for example. So the code here just works with a vector which has 5 elements, and the simplest one of these is for each, and this just replaces a loop. So for each element in the range here between begin and end, this lambda is going to be run, and this does something very similar. It just prints out each element. So let's run that and have a look. And of course it prints out 1, 2, 3, 4, 5. So it's very neat. It's a single function call, and it's passing around a function object rather than writing a loop manually. Let's look at a slightly more interesting one. How many times have you gone through a collection to find the number of items that match a certain condition? COUNTIF is an algorithm that does exactly that. And so here this will count the number of items that have a value of less than or equal to 3. So again, it works on a range begin-end and takes a function object like a functor, or since we're using modern C++, we can use a lambda. So let's run that and see how many elements have a value of less than or equal to 3. And there are 3 of them. Fantastic. Okay, onto something equally interesting. You have a collection and you want to replace some of them, but you're not sure which ones. So replace if will come in very handy. It will run over each element in that collection and only replace a value if it meets a certain predicate. So the function signature here is slightly more complicated. It takes a lambda that returns true or false, true when it should actually replace that element, and it takes the value that it should use to replace. So we're going to replace all of the elements that have the value 5. There's only one of them, with 10. There we go, we have 1, 2, 3, 4, 10. Okay, so let's look at something that's very common, sorting. So it is an extremely common use case to have a collection of items and you need to get them into sorted order. So I have a vector here which has a whole bunch of integers and they are in random unsorted order. And so we're going to sort those. Sorting only requires a begin and end iterator. It just points to the range that should end up sorted. And then using for each here, we're just going to print out the sorted values of that vector. So let's run that. And we can see that the sorted result is in fact sorted. And there are some duplicate items. Now another variation here, I mentioned that many of these algorithms have similar related algorithms, and that's the same for replace if and that kind of thing as well. Stable sort is a very useful variant of sort where it keeps items that are identical, they're evaluate to be equal to each other in the same relative position. So if you had, for example, C and B and A and B dash, where B and B dash are equal, when you use sort, you might end up with A, B, B dash C, or you might end up with A, B dash B, C. A stable sort will give you A, B, B dash C, and the reason is that these two are in the same relative order that they were in the input. So that's an example of one of the variations of algorithms that can be found in the algorithm header. So let's look at a couple more. You can find the minimum and the maximum elements in a collection or in a range. And the min-max element functions here actually return iterators. So they return iterator into the range. So for this code here, we're just going to dereference them so that we can print them out. So let's have a look and find out what are the min-max elements of this vector. And the minimum is 3 and the maximum is 8, which is very useful. Now, you probably noticed as well that when this is sorted, there are some duplicate values here, and sometimes, of course, you have a collection, you don't want duplicates, you only want unique items. So this is where making it unique, using the unique algorithm can be very useful. So this has 2 stages. Many SQL algorithms that sort of change the order of items and you want to remove some of them, the algorithm here will that finds all the unique elements that in other words, remove duplicates. Will first of all place the result at the beginning of the sequence, the range, and it returns an iterator to where the other elements have been placed. So we'll see this in 2 stages. So we're going to call unique on that vector. And you can see you get 3, 4, 5, 6, 7, 8, which is great. So the duplicates, the second 4 and the second 5 have been removed. But then we have 7, 8 here, and they are left over when the when the vector was but before it was modified, it had 7 and 8 in those positions, and so 7 and 8 have not been overwritten or removed or deleted. So what we need to do is to erase the remaining items from the end of the sequence. And now we have 3, 4, 5, 6, 7, 8, and the last 2 items of the vector that were no longer required because the resulting vector should be 2 elements shorter than the original vector have been erased. So here's a different family of algorithms, sets. So containers might contain a subset, for example, of the same items. So you can treat a collection as a set and to get the intersection of that set, like the common items that are in both. So we're going to get the intersection of all the numbers that are in the 2 vectors that we've used so far, and we're going to place them in V3. So 1, 2, 3, 4, 5, and there was 3 through 8 in this one. So we're calling set intersection there between v and v2 and place them in where v3 begin. Now, the particular method that I'm using here does not insert items, so I've pre-sized v3 to be large enough to hold all of the items if it happens that the intersection is every single element in both vectors. And then we're going to print out both of the vectors and then print out the intersection. That is the common elements between both of them. So we have 1, 2, 3, 4, 10, 3, 4, 5, 6, 7, 8, and the common items in both are 3 and 4. So that was only a few of the algorithms in the algorithm header. Some of the other ones that weren't covered were doing a binary search or finding the lower bound and upper bound. Those two are very useful. Heap operations didn't even get to them, permutations didn't get to them, partitioning didn't get to them, numeric operations didn't get to them either. There's quite a wide variety of very useful algorithms. You can see the screenshot here is the cppreference.com algorithm page, and visible on screen are about half or less of the available algorithms. So the key message here is use these instead of your own code. Many of these do things that are very common. You might have code that has been written to do exactly the same thing, but using the standard algorithm ones will give you a optimized and you can assume completely bug-free version of those operations instead. And the best link here is the page that I just showed a screenshot of on cppreference.com. And we're running very short on time, but we probably have time for a quick question and answer.
So Jim's saying, I'd like to, like Delphi, in Delphi, I'd like to see the 4x and y extended to support more operations. And I guess I kind of leads into a question I have is that do you find you're having conversations with Marco and Serena and Nick about ways to add language features from C++ to Delphi and vice versa?
We do have a lot of conversations about that kind of thing. It's not always specifically from C++, it can be from other languages as well. But yeah, we do definitely talk about language features that we can add to Delphi. And of course, if you have any specific things that you think would be really useful and would really fit Delphi as a language, you can always email any of us. Marco is the Delphi product manager, so probably him, but any of us would be very happy to get an email about that kind of thing.
Mm-hmm. I know it's interesting. I had a conversation, I can't remember who with at one point, about language features versus library features, and it was a really good argument made actually to if it can be done as a library feature, it's better than a language feature, because if it's a language feature, then it's fixed. But then later you can, if it's a library feature, you can later make a library feature into a language feature, and a library feature can be more portable and stuff like that.
That's very true. Yeah. In fact, Delphi is a good example of that because we have the parallel programming library in Delphi. And so that is taking something that was commonly requested, a way to sort of parallelize Delphi code, and implementing it as a library feature rather than that as a language feature, which I think was a good choice for exactly the reasons that you mentioned.
Yeah, exactly. So Ilya just said, super lightning, if not igniting talks. Thanks for the fun. Oh, I'm glad you're enjoying it.
I saw a question come up about a for each loop in Delphi, and I believe we have for each. So Delphi collections can implement IEnumerable. Right. And IEnumerable provides a way for the compiler to know that it can enumerate over those items in Delphi. So you can write a for each loop in Delphi very similar to how you can write it in C#.
Yeah, it's actually that's actually a language feature in Delphi, as we were talking about language versus library. Where I guess in C# or in C++, that's a library feature, right? So algorithms are library features.
That's right. Yes.
Library, which it's C++ actually kind of has this hazy thing because you have the standard library. So you have language features, and you have this standard library that are really library features, but they're so standard they're almost like language features.
Yeah, that's very true. And the contents of the standard library are actually decided. I mean, they are part of the C++ spec. There is no C++ language spec without including the STL, the standard template library. And so many of the things, such as std move, for example, which implements move semantics, it's a library method, but it's there to answer a language need, and it's specified exactly how it works and what it does. So it is effectively part of the language. The line between the two does get very, very blurred.
Yeah, I was actually a while ago looking at different languages, how they influence each other and stuff like that, and it came to a point. I was like, I don't think you can really differentiate the library from the language anymore, because they are, in so many different ones. In Delphi and Python, Python's really about the libraries in addition to the language as well. So it's really it's kind of blurring the lines. You really can't have one without the other. And
that's very true.
I actually, it was interesting, your comment about at the very beginning where you're like, code you don't write can be assumed to be 100% bug free, and then later you kind of chuckled about that. That's an interesting thing. I think that really that's kind of the one of the things I used to do a lot of interviewing for hiring developer candidates, and that's kind of the things that's kind of interesting is I think that the more senior developers kind of understand that, oh, well, it's already been done, I don't need to redo it again, where more junior developers will be like, ooh, let's figure out a way to write a loop that's even faster, and it's like, well, maybe, but don't go that way unless you have to.
Yeah. No, I have vivid memories of being a junior developer, and like always, I think the experience of being a programmer is obviously learning more and more and realizing how bad the code you used to write is, where bad can be remarkably close to the present day.
Yes.
But loops are a particular example, because in C++, I used to loop manually. I used to write code that, especially using index, I write a for loop, for int I equals 0, I is less than something. And because that was easy, and you could type it without thinking, and it took some sort of moment of realization to realize why that wasn't a good idea and what the advantages were of taking advantage of other techniques.
Well, as you were talking about that, I had to think about that. I was like, wait a second, a loop. I mean, that's not you can't have a bug in a loop. And I was like, wait a second, off by one. I've had so many bugs in loops where it's like, I'm iterating the wrong direction. And so having something where you're just describing it, and where you can look at that and say, oh, that is doing this. Instead of with a loop, you have to say, okay, they're doing a loop, and in the loop they're doing, what are they doing? Oh, they're doing this in the loop. And so there's so much more complexity introduced with a loop instead of just using one of these algorithms. So yeah, I can definitely see the advantage in being less code and less bugs by using these algorithms.
Yeah. Well, a loop like that, where you have an index variable, is you can easily have off by one. But even in C++, when you use iterators, I mean, looping using a count or an index like that is very much not C++. But even using an iterator, you can get the condition wrong. You loop from the beginning iterator and until you get to the end. Like the end actually points just past the last element. If you happen to get that condition wrong to be less than versus less than or equal to, or something like that, you can also introduce a bug there.
Yep, exactly.
And when you have for each, you just know you're doing something for each item.
Exactly. So yeah, I'm thinking about it might be useful to implement some of these algorithms for Delphi, especially like you said, we don't have exactly the same things. But we have some similar things as far as anonymous methods and enumerables. Jim saying, and records can implement a get enumeration method without an interface, which is true. And
I think that's one of the language quirks. You don't actually have to implement the interface. The compiler just magically recognizes it if the right methods are there.
That's right, it does. It doesn't have to be necessarily an interface, exactly. When will we have for each loops natively in all ordinal types in Delphi, or is it already there?
To be honest, I am not sure about that.
I think it's already there for all enumerable types.
Well, ordinal is in something like an integer. You wouldn't want to.
Yeah, I'm not sure how you do for each an integer, But most enumerable types, like we were saying, if it's a collection or array or something like that, then you can for each those.
And I believe you can over an enum as well. It's been slightly too long since I last wrote some Delphi code, so don't quote me on that.
Jim's saying for in even works with enumerations and enumerated sets.
Oh, fantastic.
Yeah, Walter's asking this question. There's already there. I so many times ask guys like, "Oh man, it'd be so nice if we could do this," and someone's like, "Oh, you can do that." I'm like, what? I thought I knew this better than this. Okay, so thank you so much, David, for that one.